Hi everybody. Obviously a tough day in class today just because we're talking about something that's really hard and it's going to take time for us to get it, but I think if we just stick with it and push forward, we can do this as a team. Apologies on the late video. I just got back from helping a friend of mine from Rice prepare for an interview that she has, anyways, I'm home now and I'm happy to record this video. So let me kind of walk through what we did in class today and let's see if it makes a little bit more sense now. So imagine a scenario where the Gatorade beverage company says if you drink Gatorade, you will run faster than if you don't drink Gatorade. So they're saying if you drink, and let me close out of this menu, I'm sorry guys. If you drink Gatorade, then you will run faster. Well, I want to test out this theory because I want to know, are they lying or are they being serious? So in order to test any hypothesis, we need to use a statistical test. And here's the way we do it. We have our null hypothesis. H naught is our null hypothesis. And the null hypothesis is always that whatever you're testing does not work. In other words, that the Gatorade doesn't work. So I would say the hypothesis is that the mean speed without Gatorade is equal to the mean speed with Gatorade. That's the null hypothesis. Then we have the alternative hypothesis. The alternative hypothesis, which is in this lighter color, the alternative hypothesis is always the one that says the effect works, the medicine works, the SAT program works, the Gatorade works. In other words, that the claim is true. So in other words, that the mean speed without Gatorade is less than, in other words, I can run maybe 20 miles an hour instead of 10 miles an hour. I can run faster than the mean speed with Gatorade. Alright, so this is what we've got so far. And I got my first hypothesis, my second hypothesis. Now I have to test, is this hypothesis true or not? So here's what I do. I take 100 people and I give them Gatorade. I take 100 people, no Gatorade. And then I measure the mean speed and I measure the mean speed. Now, so I have these 100 people who drink the Gatorade and I have their average speed. I can probably get their standard deviation of the Gatorade people. And I can probably get the standard deviation of the no Gatorade. And now the question is, well, is what these people did actually significant, or are they not doing anything? Well, let's find out. So let's assume that we find that the speed is 20 miles per hour and the standard deviation, I don't know, is 1 mile per hour. And over here, we find that the mean is 19 miles per hour running and the standard deviation is 2 miles per hour. Now I want to check, does Gatorade actually work? Here's how I check it. I say, well, this is the population of people. And I can draw some distribution. So this is the no Gatorade, or this is the speed here. And we have some curve. And the mean speed is 19 miles an hour. And I want to know, is this 20 miles an hour a significant improvement? So here's 20. So I can find this probability. Normal, CDF, 20 to infinity, 19, 2. And I'll get some probability here. In fact, let me pause the video and see what I get. Give me 1 sec. Let me go ahead and pause this video. Alright, so doing this, I got that this equaled 0.31. So what that means is that there is a 31% chance that people who don't even drink Gatorade, right? I haven't even done anything with the Gatorade. These people here who don't even drink Gatorade, there is a 31% chance that they run 20 miles per hour or more. That's a pretty high probability. 31%? That's pretty high. Because this is so high, I don't have enough evidence to say Gatorade works. If this had been 1%, then I would have said it is really rare to run this fast without Gatorade. Gatorade must have done something. But now, I don't know that Gatorade does anything, because this probability... Let me explain this a little bit more deeply with some more math. So the p-value we got, or the probability, was equal to 0.31. And here's where we know what is going on. Here's where we know. If the probability is greater than 0.05, in other words, there's a higher than a 5. Let me turn off my video here. I think it's slowing things down a little bit. Hold on 1 second. Hold on 1 sec, folks. Let me stop the split screen. Okay. So, if the probability is greater than 0.05, then we fail to reject hypothesis. Non-math words. In non-math words, it says if the probability is greater than 5%, we cannot conclude that Gatorade works. Because the probability is so high. In other words, the probability was 31% that these people ran faster than 20 miles an hour. So I don't know that the Gatorade is doing anything. Maybe I just picked people from in here. So the Gatorade might not do anything. So I can't conclude that the Gatorade works. In other words, I have to say that H naught, which if you remember H naught was that the speed with Gatorade is equal to the speed without Gatorade. I have to say that this is true. That having Gatorade, I can't reject this. Gatorade doesn't do anything. My test says not do anything because this probability is so high. It's so high. So I cannot reject this. I have to assume this is true. I don't have enough evidence to reject this. So H cannot be rejected. Alternatively, this is another rule. If P is less than 0.05, then we reject the null hypothesis. In English, if the probability is less than 5%, we conclude that Gatorade has a statistically significant effect. In other words, if we come back here, we reject this and we say, yep, the speed without Gatorade is actually less than the speed with Gatorade. Gatorade does something. We can only conclude this if the probability is less than 0.05. If the probability is less than 0.05. Now, let me spend about 3 or 4 more minutes and then we will call it a day. I want to talk about the error, and this is where we had a little bit of problems in class, and that's fine. We will get it. We will get it. Now, we have the null hypothesis, and the null hypothesis, remember the null hypothesis was speed with Gatorade is the same as speed without Gatorade. This null hypothesis, it could be true, it could be false. By the way, I got this tree idea from Alex Garcia, so I want to give Alex a big shout out here. The null hypothesis, which was that Gatorade speed equals no Gatorade speed, right? This was the null hypothesis. So it could either be false or true. If the null hypothesis is true, so I made a true statement, what could happen? Our test, and remember by test I mean we could, this is the test, and the test is using the probability. By the way, this is what I mean when I mean the test, I mean this what I did here on the green and the maroon. The test could either say accept this or reject this. In other words, it could say failed to reject. Another word for this is accept. We could accept the null hypothesis or we could reject the null hypothesis. If we accept the null hypothesis, what we are saying in words is that Gatorade does nothing. Because we're accepting that Gatorade speed is equal to non-Gatorade speed. This is the right choice. This is good. Because the null hypothesis is true and I'm accepting it. That's good. If I reject the null hypothesis, what I'm saying here is that Gatorade does something. Gatorade does something. That would be wrong because this is true. We're assuming this is true. If this is true, then the Gatorade speed is equal to the non-Gatorade speed. That means Gatorade does nothing. This is wrong. This is a mistake. This is a mistake. Similarly, if we come over here and say, if the null hypothesis is wrong, in other words, if this is wrong, if Gatorade